Let us look at proposition number 7 of book 6 of Euclid's Elements. The proposition says if two triangles have one angle equal to one angle and the sides about the other angles proportional and the remaining angles either both less or both not less than a right angle, then the triangles are equiangular and have those angles equal the sides about which are proportional. Quite a mouthful. So let's see what this means. So here we have two triangles ABC and DEF such that angle BAC equal to EDF and AB is to BC as DE is to EF. That is how these triangles have been constructed. And it talks of, the other angles being either less or more, not less, which means greater. So either lesser or greater than a right angle. So which means we have two cases. So let's say angle ACB and DEF, they both are less than 90 degrees. So if that is the case, let's assume, we are going to use proof by contradiction. Let's assume that angle ABC is not equal to DEF. So if they are not equal, one of them has to be greater. So let us say ABC is greater than DEF. If ABC is greater than DEF, that means there must be some point on AC where angle AB and that point would be equal to DEF. Yes. So let us say that point is G. Now let's join B and G. So here angle ABG is equal to DEF is what we are assuming. If ABG is equal to DEF, that means that angle AGB is equal to DFE. Why? Because we have said ABG is equal to DEF. These two angles are anyhow equal. That means two angles of ABG triangle, these two triangles of this triangle DEF are correspondingly equal. That means the third angle has also should be equal. Okay, which means triangle ABG and DEF are both equiangular. Now, if they are equiangular, that means AB is to BG is equal to DE is to EF. But remember, we are given that AB is to BC is equal to DE is to EF. So in both these equalities, DE is to EF is being compared with. So which means since two ratios are being compared with the third ratio, that means the first and second ratios are also equal. So that means AB is to BG is equal to AB is to BC. AB is to BG is equal to AB is to BC. Now here again, two magnitudes are being compared to a third magnitude because AB is common in both the sides of the equality. AB is to BG is equal to AB is to BC. So that means BG is equal to BC. Now if these two line segments are equal in this triangle, so in other words, these two sides are equal. That means the angles opposite to these sides will also be equal. That means BGC is equal to BCG. And since these two angles are equal, that means this is also less than 90 degree. The equality of these two triangles implies is that this angle, angle AGB, is going to be greater than 90 degree. Why? Because a line standing on a straight line makes adjacent angles equal to two right angles. And since this is less than 90 degree, this has to be greater than 90 degree. Remember, this we said is equal to this angle. That means this angle is also going to be greater than 90 degree. Remember, we have reached a contradiction because we assumed what? That ACB and DFE are both less than 90 degree. Here we are arriving at a conclusion that angle DFE and angle ACB, they are supposed to be less than 90 degree, but now we are saying that angle DFE is greater than 90. Now, because we have reached a contradiction, so our original assumption was wrong. It means angle ABC is equal to DEF, angle BAC is equal to EDF, and angle ACB is equal to angle DF. That means these two triangles ABC and DEF are equiangular. Now that was the first part. The second part is assuming that angle ACB and DFE are greater than 90 degrees. So following the same logic, we can show that BC is equal to BG. That means these two angles are equal. Angle BCG and angle BGC. They are both equal. That means angle BGC is also greater than 90 degree, but that creates a problem because in triangle BCG, we are ending up with two angles which are greater than 90 degrees. So that means since we have reached a contradiction, the assumption was wrong, and we can say ABC is equal to DEF and angle ACB is equal to angle DF, and we are already given that angle BAC is equal to angle EDF. That means these two triangles are equiangular. So that is proposition number 7 of book 6 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share it. That's it for now.